Okay, so as I said, second part of this lecture we're covering basic operations as far as stuff that you need to know. This is all stuff that you guys probably know. Essentially in this class, if you can add, multiply, subtract, and divide numbers, you're going to be fine. And obviously, I think everyone has calculators today, so you're going to be pretty much fine no matter what, as long as you're able to get the stuff I'm about to cover. Now this essentially is stuff that's corresponding with the part of your reading for this week. The reading in Appendix A of your book covers this same material. So after you watch this lecture, you should go and actually read the book and do the practice problems that are in Appendix A in the book. But okay, one thing we're going to see a lot in this class is that there's various shorthand symbols that are used to represent different mathematical functions and also different statistical techniques, and we're going to need to learn those. One of the most important, obviously you're going to see the most, a variable is usually going to be denoted by an uppercase X. So this represents a variable. Now we'll talk a bit more about what a variable is next week, but in most cases our variable is represented by an X. A single variable would be represented by X subscript 1. If there's, say, two variables here, X subscript 2. We'll talk about that a bit more next week. Don't worry about this part as much now. This next part's a bit more important for now. But one thing that you're going to need to know is that in statistics we use the Greek letter sigma. That's what this little thing right here is. That's a sigma. We use that as a symbol to represent summation. It's a very common summation notation throughout mathematics and various scientific fields. And what this basically means, so let's say if we see this here. So sum of x, that's basically what this is telling us, sum of the variable x. Now I'll cover some examples here later on, but for now, let's just go over this. Okay, so what would this mean? This would be, okay, this would essentially say the sum of x, sum of the value of x, which would be our variable here. If we saw the sum of x squared, essentially saying sum of the squared values of x. Well, if we saw it this way, this would essentially mean that we square the sum of the values of x. So we do what's in the parentheses first, and then we square. We'll go over order operations here in a few minutes. More examples here, sum of xy. If you have more than one variable in a study, usually your first variable is going to be denoted as an x and your second is a y. Actually, I just spoke there a little bit. In most cases, your x would be what's considered your independent variable and your y your dependent variable. If you guys have had research methods class, that'll be familiar. If not, we'll be talking about that next week. But again, this is essentially telling us to multiply each x and y value, then add those products together. So we would multiply this first and then take the sum of all of this. This will make a little bit more sense after we go over our order of operations stuff on the next slide. This one's telling us the sum of the values of x times the sum of the values of y. One last thing you want to remember is that a constant is any value that basically remains the same if there's no variation in it. Okay, so that was a little quick. Your head's probably spinning a little bit after that if you're not familiar with this already, or most of you probably are, so it's not that big a deal. But, so maybe we should backtrack a little bit and talk about order of operation here. Okay, now we're going to make it a little more complicated and make it pretty much congruent to what you'll be seeing in this class with your formulas. Let's say here we have two variables. We have an independent variable. Go back a minute. Independent variable x and our dependent variable y. This could be anything really right now. We don't really need an example for this, but let's say that we're trying to just figure out if the number of cheeseburgers you eat is related to the number of the hot dogs you eat. And so we have cheeseburgers and hot dogs. How many you ate? And these basically each equal a different person. And if we wrote this out a different way, this is our variables. These are our data for each variable. If we wrote it out a different way, we could have x1 would equal 2, x2 would equal 3, and so on and so on. Same thing with y. I just wanted to illustrate that again. Okay, let's start a bunch of examples here. And what I want you guys to do is go back and try to compute all these on your own before I give you the answers here. Alright, hopefully you've taken the time to go and do that. It's going to help you a lot more if you do the practice. But okay, our first one here, what's this telling us? Well, it's essentially telling us to get the sum of x. So we're essentially doing our summation notation examples here. I gave you some of those earlier, now we're going to go through the actual examples. So this is saying get the sum of x. So what does that mean? Well, it means take each of the values in our x here. Erase that. And basically add them up. So pretty straightforward there. This would be 2 plus 3 plus 4 plus 1. Which is pretty straightforward, gives us 10. Okay, our second one here, sigma y. What's this telling us? What's telling us to get the summation of the y variables. So 5 plus 3 plus 1 plus 1. Once again, adds up to 10. Next one here, now we've thrown in an exponent. The sum of x to the second power. Okay, next one we get a little bit more tricky here. Again, sigma x squared. Well, the first thing we want to do here, well, we're still going to follow our order of operations. So this one's sum of x squared. That means that the first thing we need to do is square each of our x values. Which would give us, okay, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, and 1 times 1 obviously equals 1. You can see I wrote these out here. 4, 9, 16, 1. That's the square of each of these values. And then so we got the square. Now we sum them. So 4 plus 9 plus 16 plus 1 equals 30. Okay, so we got that one done. Okay, what's this next one telling us to do? It's kind of similar to this one up here, except, okay, we got parentheses now, so that's telling us the first thing we do, again, going back to our order of operation, is do what's in the parentheses. So we take the sum of x. So come back again, so we get 10 squared, which gives us 100. 100. So again, see, since this one had the parentheses, we do what's in the parentheses first, and then the exponent of that entire value. Alright, for this next one, it may help to... Okay. For this next one, sum of xy. It may help to actually look at the variables a different way. Again, x subscript 1 would be our 2 here, x subscript 2 would be 3, x subscript 3. Each of these variables in a study are going to correspond to each other. So f subscript 1 and y subscript 1, that would be corresponding to the same person. So let's say that represents a person named Bill. How many hot dogs and how many hamburgers he ate. This one maybe John, Mac, and Rob. And that's, again, you've got to correspond with each of those. So this one's telling us, okay, we want to multiply x and y, so each x variable is going to be multiplied with its corresponding y variable, which is the variable with the same subscript. So 2 times 5. So if we do that, we get 10, 9, 4, 1. Okay, 2 times 5, 3 times 3, 4 times 1, and 1 times 1. And now, okay, we did the first part there, now we sum this, 10, 9, 4, 1. Which gives us 24. So the answer to this one would be 24. And I hope you see how that was done there. Okay, again, mix it up again here. Sigma xy in parentheses. Alright, so how do we do this one here? Well, this is actually done the same way. It's just a more easy way of representing it by actually putting the parentheses in. It's 100% clear that we should do the x and y first and then sum those variables. Now if it's written this way though, it would be the sum of x times the sum of y. So we get the sum of x first, which we know is 10, and the sum of y, which is also 10, so that would become 10 times 10, once again equaling 100. Now, I hope that, again, you're going to be mainly following order operations even when you start throwing the sigmas and variables in. And one thing you want to remember again when you're adding variables, that you have the variable and its subscript tells you how it could basically which one lines up with the other variable. Now the equations we actually do later in this class, particularly when we get to inferential statistics, will be a bit more complicated than this, but as long as you follow these steps we went over and do the practice, and we'll also obviously I'll give examples for each of those when we get to them, you should be fine. But if you ever have any questions or have any problems when doing your calculations, let me know, and I'd be happy to mentor students one-on-one. I think most of you will be fine on that. Due to this nature of this class, I'm not going to make you show your calculations because it'd be really hard to do that on the quizzes and tests and whatnot. So you're really going to be checking yourself as far as, am I calculating this stuff correctly? And the main way you're going to be able to do that is, again, do the practice stuff that I give you. Do the quizzes, do the practice, and practice all the stuff in the book. Alright, I think that's enough for this week. Again, you guys want to go and you want to read through Appendix A, do all the practice problems there. And I think that should prepare you pretty well. Also, obviously, read Chapter 1, and you guys should be ready to move into the material we'll be covering next week. Alright, have a great week.